Hi guys, I am here with Dr. Charles Lee, a senior lecturer at Waikato University. Thank you for joining me this morning, and so tell me about your academic pathway in life so far, so the different qualifications you've received and the different courses you currently teach.
Right. So I have a somewhat accelerated pathway. So I did not do a master's degree. I did my undergraduate degree in Taiwan, and which was equivalent to a bachelor with honors. So I entered directly into a PhD program at Waikato. And since then, I've basically stayed at Waikato through a number of research contracts. And I think the courses I'm currently teaching, I currently coordinate two courses. I teach microbiology at the third year level, so that the highest level, and then also at the graduate level, I have a graduate course in human and applied microbiology. I also contribute to a number of courses, including first year biology, and so on.
Cool. And so, why did you decide to pursue a PhD?
So this is a very simple question to answer, because in biology you need a PhD.
Cool.
It's as simple as that, right? So for a lot of other fields, this is not an easy decision to make. So for example, in engineering, in geology, and in disciplines such as economics, and certainly in education. So in those fields, getting a PhD is basically a declaration that you're going to be an academic. There's not a lot of alternative employment pathways once you have a doctorate in engineering. But in biology, due to a variety of reasons, a lot of it is historic. You basically cannot get a real job, a job with real responsibilities, unless you have a PhD in biology.
Wow.
So it's a very high barrier of entry, which also means that there's a lot of biology PhD graduates. And I think that, so because I wanted to be a biologist, I did not know what kind of biologist I wanted to be. I did not know, what kind of work I wanted to do. But one thing that was made very clear to me was that you needed a PhD.
Yeah.
So doing a PhD the decision to do a PhD was not hard. The decision as to where I do the PhD, that's different, right? So I ended up doing my PhD at Waikato, not because I came, I said, I came to Waikato and therefore I should do it here.
Yeah.
And I would say the same thing about any other university. This applies to even Oxford, Cambridge, or Harvard, because as a PhD student, you're less impacted by the institution that you do it at. It's much more about your advisor and the lab in which you work.
Yeah, definitely.
Because at the end of the day, right, you could have a degree, a PhD from a very prestigious university, but if your PhD does not result in good publications, does not result in a thesis that people can read and judge objectively, then it's not going to carry much weight, right? Vice versa, if you do a PhD at a less prestigious university, but you get lots of good publications out of it, that's what people judge you by. So this is where it's very different, where a PhD is very different from a bachelor's degree or a master's degree, which people certainly look at the prestigiousness of the institution that you finished it at. As a PhD graduate, you are judged much more on the quality of your work than the specific institution that in which you did it. And PhD is a long process. Right? So in New Zealand, it takes a minimum of 3 years. Most people finish it in maybe 4, sometimes 5. That's a long time to be working with one group of people.
Yeah, definitely.
Right? Yeah. And you definitely want to make sure that you have a good advisor who's able to give you the support that you may need. You want to work in a lab in which the atmosphere is collegial, right? People help each other. People are be surrounded by people who are very smart.
Yeah.
So I think that when I came to Waikato, I joined my PhD advisor's lab as a research assistant, and he had a very interesting project, and I find that it was rewarding, challenging, but rewarding to work with him. So I decided to do a PhD with him, and that is, I think, a good way to approach this. Sometimes, a lot of the time, students are expected to jump into a situation or to commit to a decision without necessarily a lot of information. And the best way to collect that information, one, is to ask questions. And secondly, if you really wanted to know what working in that particular field is like, volunteer as an intern, right? Work basically for free, to gain experience for a few weeks, for a few months, and then you get a really handle on whether you enjoy it or not. And then during that time you get mentorship, you can get help with scholarship applications and things like that.
Cool. So, what are some of your past and current projects?
So I have been primarily active in studying Antarctica, so terrestrial Antarctica, the dry valleys, the microbiology of terrestrial Antarctica. But I've also been involved in lots of other habitats. So my PhD was based on some microorganisms found at deep sea hydrothermal vents. So for those samples, we had to take a submersible. And some of our sites are, I think the deepest site we had was 4 kilometers deep. So we had to take that submersible, collect the samples. So I've done that. I started off with doing geothermal work, and that extended to terrestrial geothermal environments. So I've been working in the topovolcanic zone, and I've worked in Yellowstone. I've worked on Mount Erebus in Antarctica. But I would say that most of my research so far has been focused on Antarctica itself.
And so, which one would you say was the most shocking or most interesting project that you've underwent?
They're all really interesting, and I think that's really, and I've been fortunate that through my various research projects, I've been able to do things that I find interesting. And sometimes it's also about you finding what's interesting about what you work on, right? A lot of the time, it's not always obvious from the outset that something will be interesting. And it's a tough one. I think that Antarctica has certainly provided a lot of opportunities in which with which I could extend my science. Although I'm doing more and more work in geothermal environments, and they come with their own challenges. I think life. So I would summarize my approach to science as looking at the extremes, right? From the human perspective, what we consider to be extreme environments, because these extreme environments impose conditions under which only certain types of metabolism could work, and that really allows us some unique insights into how microorganisms survive in those environments.